Welcome. I have a lot to say, so let's start. This is me. I'm Daniel Stenberg. I'm here today to talk a little about curl. You might have heard about it a while. It's a little tool. It's a command line tool and a library for doing internet transfers, in case you didn't know. It's been around for a while then. It all, of course, started back in the day when we didn't have curl. And in this great year when this movie actually came, I was working in IRC bot, as you do, of course, we've all been there, and I was going to add a currency translation service to my bot, and I needed to download HTTP or data over HTTP for new currency rates every day. So I didn't Google, because Google didn't exist, but I found a tool called HTTP GET. It was released in November 1996. It actually downloaded HTTP. I had no idea what HTTP was actually, or how it worked really at that point in time. That was about 100 lines of code, really, really simple. Didn't really work exactly the way I wanted to, so I patched it, sent the author some patches. We should do this, and you know, Rafael Sagula is the name of the guy who wrote the first version. So this was November 11, 1996. He made HTTP GET 0.1. I became the maintainer and made 0.2 in December 1996. Anyway, then I found another site with currency rates on Gopher. So I added Gopher, cool. Now we can get more currency rates for my currency translation service. And HTTP GET was a stupid name because it wasn't just HTTP anymore. So I renamed it to URL GET in 1997. And then I found another site with even more cool currency rates on FTP, right? So FTP is a little bit more complicated, but I added FTP support too. And then someone suggested, and someone wanted upload support as well, and then I added upload support so we can also send data in the other direction. And then URL GET became a stupid name because it's not only the GET anymore. So I renamed it again. It's just something with URL, a client, you know. C URL, maybe a pun, but so okay, you can pronounce it curl. Naming is really, really difficult, right? So curl, good enough. We go with curl. 1998. There's no HTTPS here, but oh, we figured it out. You should do that too. We did that in '98. Now you can do HTTPS too. And then why not telnet? Someone added that. And then yeah, we should also add DICT, the best protocol. And then we went on, you know, we added pure protocols over time, 2003, 2005, 2006, 2007, 2009. You know, more and more protocols, why not? Here came all the email suites of protocols. And why not a few more, SFTP, SAP, and we could do more and more and more. And you know, so many protocols we don't even remember all of them. And in 2026, you can see 22, 26, yeah. So we added MQTTS just recently, so it's going to be the latest one in the release in exactly 1 week. So now 29 different protocols. So yeah, it's been a journey, 96 to 2026. And the number of lines of code, as I told you, we had about 100 lines of code back in late 1996, and now it's roughly around 172 maybe. We've had a little dip recently. We removed some crap, so we actually... but anyway, it's an amazingly linear journey through time. It's just more code over time. And number of commit authors, similarly. Well, it starts on 2010 when we switched to Git. But anyway, it's going up there. It's not me alone. It's a lot of people. Interestingly, on this graph, you can see the green one here is those are the people that only ever wrote one single commit. So that's a little bit over, closing into 1,000 authors out of 1,400 only did it once. Anyway, contributors, then also counting people who just reported bugs or helped out, otherwise advice stuff. Yes, 3,600 names in the list by now. And yes, it's a bump there when I went back and sort of retrofitted all the old names, so that's why it's a bump there. If I don't explain it, everyone will just look at that bump. And number of command line options, of course, very important. There was actually, in 1996, there were actually no command line options, I think. But anyway, when we did curl in 98, we had 24 options. And now we're on 278 something, 79 maybe. I don't remember the exact count, but a lot. API calls in libcurl, because we created libcurl, the library, in 2000, and it was fairly simple back then, and then it just grown as well. You know, everything just, you know, it grows and grows and grows and grows. Number of releases in curl we have done now 200, and similarly to number of command line options, 270 something. Steady pace all through time. And all of that code, all of that development has also made us support quite a few operating systems. So nowadays we can count more operating systems than most mortals can actually ever, you know, remember or mention, or no serious person can do that. And of course, on anything that is CPU, has any CPU with 32 bits or larger, we can run curl on. So pretty much anything these days. And we have been around on more than one planet too. Super awesome. So yeah, it's over time, a lot of code, a lot of efforts, and you know, now it supports a lot of things on a lot of platforms and with a lot of different combinations. So it's literally become this Swiss Army knife of, in particular HTTP, but internet transfers in general. Whatever you want to do, transfer data over internet in a protocol, you know, in a standard way with URLs. Curl is your friend. So it has then taken us to this scenario, that it's literally in almost anything that can, you know, speak over internet today, curl is probably in there. So, you know, every server and internet connected thing on the internet, all the big services like, you know, you can see Google Photos, YouTube, Spotify, Facebook, and all the big games you can see there, Roblox, Fortnite, the phone operating systems, iOS, Android, all the cars nowadays, I'll come back to that, you know, the robots, printers, kitchen devices, all the game consoles. It's literally in pretty much everything that is connecting to internet. We're counting nowadays around maybe 30 billion installations. It's really hard to assess exactly, or just more of a guess. It's literally in many installations in every single mobile phone, which is just an insane amount, just that. So whatever, the question usually becomes, so what's in curl and what's not curl? But basically, what's in curl is really simple. If it's a URL standard somehow, it doesn't have to be an established sort of IETF standard, but as long as it's an established standard, it does uploads or downloads, and it's sort of, we can ignore the content, then it's probably for curl. That's why we have those 29 protocols, because they are more or less like this. And if it's not, if it doesn't fit all those three, it's probably not for curl. That's basically what we do. And then we, of course, provide the command line tool and the library for that. But okay, at the same time, we all did all this, and looking back at it, it seems natural, because why wouldn't we do that? But it's been 30 years. The internet was a little bit different in 1996. For example, in 1996, there were 36 million internet users, right? Where we have exploded at about 166 times since then. Where the websites, there were 250K websites in 96, and now we're at 1.1 billion websites, roughly. That's also pretty significant growth. So, you know, everything has really, really exploded. The average internet, you know, the connect time you connected to the internet in 1996, this was before the, you know, the V90. We did things at 30K bit per second. The average in Sweden today is 190,000 kilobits. So yeah, that's a difference. So, I mean, the internet exploded, the web exploded, and everything has, of course, and we've sort of just followed along. In 1996, and a little bit of an explanation why we have all these protocols, in the world and the internet in 1996, and actually in the beginning of the 2000s, I think we all thought that we would have would have that plethora of different protocols. We would use different protocols for different things. And over time, you know, we have just transitioned everything over HTTP or HTTPS nowadays, which is also different. And of course, back in 1996, open source was serious fringe concept, in particular because open source, the term, wasn't coined until 1998. So in 1996, we actually just made code. There was no term for it. Possibly free software, but in my world, we didn't even say it like that. We just I wrote code and shipped it, here it is. There was no word for it. But today, everything is built on open source today. And everyone is aware of open source. Basically, everyone has an present knowledge, awareness, and an attitude or something. You have to relate to open source somehow. In 96, you certainly didn't. And just the amount of compute in the world. In 1996, when I developed my first stuff, that was a Pentium 100 megahertz, my 8 megabytes of RAM. Nowadays, we have multi-gigahertz things in the pockets with, I don't know how many cores we have just in the pocket or in your fridge, car, printers, everything is much more powerful than your desktop computer was back then. Basically, everything has just exploded, and of course, that has helped, and we have exploded into an internet and web world. And we were at the right time, so we have just developed along with it. And it has led to some other fun things, like this NASDAQ building photograph. It was actually an IPO many years ago by now, but it's fun because it's a curl command line on the NASDAQ building. And one of the other favorite, just slowly ending up everywhere in the world, and so, then you can get fun photographs, or like this billboard in Silicon Valley. This was a long time ago, basically 15 years ago. So it shows it's a very blurry photo, but it's a fun command line because it's, totally pointless and stupid. What is this? I blogged about it, and the market director contacted me. He was embarrassed. Anyway, and even modern days, this was actually just 2024, on bus stops in San Francisco, they had curl command lines, so that's fun. Curl is in all these places, and curl is a license under an MIT, it's actually patched MIT license, but anyway, it says you can do whatever you want with this as long as you don't claim it's yours, and you just have to ship this license somewhere in the documentation. A lot of people show that license in an about window somewhere in the product, like in the car. And if someone has a problem, they can find that license, and that license has my email address. So then they contact me when they have a problem. And I'm an expert on everything. At the time, this was actually many years ago now, but I have no idea what it is. I didn't find the product then. I don't know. Some kind of product in Toyota. Yes, I have a bunch of those emails collected because I get these quite regularly from people finding my name in different products, and I usually, I don't even know what they're talking about, what product, what they're talking about. And I guess that's a sign of our complicated world, when it's easier to find me and ask me questions than actually contacting whoever made the product, the car, whatever they have problems with. But of course, that's not only end users, because doing something that is used in all these places then actually end up in companies doing this, and companies are concerned about what they're using. At least they are sometimes. And then they can email me and ask me, or just maybe not just so much ask, but require me to respond immediately, within 24 hours. Do I use log4j in my product? Which is fun, if you know, because curl is 100% C, as far as you can be away from log4j. But anyway, this was, of course, one of these Fortune 100 companies. And I typically just ask them to pay me for support, and then I will answer them, and then they never come back to me. Like this, the Department of Energy, they apparently also use curl somewhere. But they gave me a few more days, actually, to respond. A lot of stupid things. And also, curl being this Swiss Army knife kind of thing that speaks, a lot of protocols, perhaps most known for HTTP. You can do a lot of things with it, right? And sometimes when people find a security vulnerability, perhaps somewhere, you can show that off with a curl command line. You can do this, and something nasty happens over there, right? And sometimes when that happens, for example, in a Cisco device, just randomly picking one, you can address that problem by just, adding that little. That's the beauty of when they actually publish the security fix here. Sort of, yeah, then you know you have a sort of a presence in many places. A genuine true example, actually, from like 5-6 years ago. Right, and it's also really fun of being sort of reaching somewhere and getting known, being used everywhere, because it's used in a lot of, so I'm collecting these fun screenshots from TV shows and movies, which is interesting and ego boosting. Of course, in all of these cases, they're actually using curl pretty accurately even. This is, in particular in the Mr. Robot one, is actually, since I have done these stills, you can actually see the command line options that we've used. And they actually use some sites in the screen dump, so you can actually go to those sites and they actually exist. They made them up, or they created those sites they use. Fun thing. So, okay. That's a little bit about the journey from nothing to many places. So why? I mean, why would every one of these use curl? Why not something else, right? And from my point of view, it's, of course, slightly hard to understand or explain, but it really is a providing the features these users want is, of course, sort of the primary thing, but also that it actually runs on all these different platforms. You can build whatever you want, and you can move on to your next platform, next generation, whatever, and curl will run there as well. Embedded devices, Linux systems, Windows systems, it's the same command lines, it's the same API. It's everywhere, and it's easy for you to just bring it on to whatever you do. And it is reliable. We've proven ourselves since a long time that whatever you do with curl, it's probably going to remain working. It has worked for decades, and it's probably going to continue to work for a few more years. And it's free, which is a blessing and a curse for me, but it's really a good vehicle or a way to make sure that everyone can actually use it without limitation when they want to. And ship it in their products, ship it in their operating systems, and ship it in their phones and whatever. So these are the simple reasons. And then people, when I say 30 billion installations to anyone, they say, wow, then you're rich, right? But we shipped curl open source from the beginning, or the first version, of course, of HTTP GET, it was free and open source when I got that one. But even then later, when we rewrote everything, I always wanted it to be open source. There was never a question about it not being open source, because how could I? I wanted to be as cool as all the other guys who did cool open source, and I wanted curl to primarily be possible to run everywhere, and to be able to run everywhere, I need everyone's help, because I certainly can't make it run on all those different. Back in the 90s, you know, we had a bazillion of different Unix flavors, and I wanted to run on all of them, but I couldn't do that. So that was sort of obvious for me. I wanted to contribute back, and I wanted to get contributions back from other people. So, from my point of view, curl would never have become what it is if it hadn't been open source. I would have sort of just given up a long time ago, and no one would have used it, and we would have gotten something else instead that someone else would have done open source. So it wouldn't have worked without it being open source from the beginning, and still. And how do we do this? It's pretty simple. You just, pull up the relevant RFCs. There are a few newer ones too you can actually figure out. So my updated list stops at 9204. There are a few more modern ones you can also go through, which is a busload of documentation. It's actually about 1.6 million words, which is then more words than actually in the entire Harry Potter series or the other, smaller novels. So a lot of words. Of course, no one actually reads those RFCs from the beginning to the end, but there's a lot of information, and a lot of data, and a lot of stuff to relate to. Just showing that it actually helps have been around for a long time, because we have polished the machine for a long time, and it seems to work. Things are complicated on the internet. It doesn't really work the way it says in all those RFCs. In being everywhere doesn't mean that we are a big, complicated machine, and I said we are more than 3,600 contributors in total, people having helped out, people with names I have added to a list, said thanks to them. But we're about 60 to 80 contributors per release. We do releases every 8 weeks. So, and we're a small core team. We're around 10, 20 people that have been present in the project for the last 10, 15 years or so. Most of everyone are volunteers. I'm the only one who has been doing this full time for several years by now, but most of the people are, from my point of view, volunteers. They show up, they contribute something. No, I don't pay them, no one in the project pays them, but a lot of contributors these days are, of course, they work for a company somewhere, and that company is using curl, and so they might contribute on work hours. But from my point of view, there's no difference between someone doing it as their hobby or work or whatever. They, people show up, fixing bugs, adding features, or complaining. I don't know where they come from. We're a huge, loosely connected bunch of people, basically. And it seems to work, rather efficient, actually. One of the things that I maintain is the reason why curl works, why curl is still a sort of a preferred solution in many ways, is that we really emphasize sort of reliability and predictability. We don't break existing users, we don't break use cases, we don't break APIs or ABIs. You can actually still, the examples we provided in 2006, they still build and run. You can sort of go with the examples we did 20 years ago, and you can still build and run them. They work exactly the same as they did back then, which is, of course, something we work really hard on. It's not easy to provide, but it's one of these things that makes it convenient and really useful for all the users, that bumping up to the latest version should never be a really big problem or concern. Of course, we have bugs over time, of course, so it's not strictly true, but generally. And luckily, unfortunately, and what is, I think, one of the biggest assets of curl is, of course, that we're entirely independent. We're not even a legal entity anywhere, so we're not owned by a company. We're not under any umbrella organization. We're totally free to do whatever we want and say whatever we want. There's no one that actually controls whatever we do. We just try to do internet transfers the best we can for whoever wants internet transfers. And everything is public, and we make this to as extreme as possible. So whatever decision we do, all the conversations, every stupid security report we get that is just awful, we publish everything as soon as we can. So transparency and openness is really key here. But also, that's also another way to build trust, right? You can always just see what we do, check out if you think that's the right way to do it, and if you trust us or not. And of course, we do everything on GitHub since 10 years back, 15 years back or something. And a few selected people don't have push rights. So it's not just me, even though it tends to be some sort of a slightly false image that I'm alone on this project, but I'm not. I think we're 15 persons who have the rights to actually push to Git, and there's about 5, 7 who actually do that regularly. So we're a bunch of people trying to just enhance internet transfers forward. And as I said, everything is C89. Classic old ANSI C, the way we did it in the early 90s. That's the way we do it still in curl. And every once in a while, we bring up the discussion, should we bump it to C99 maybe this year? Nah, let's wait another year or two. It's too modern for us. It has mostly been, for a long time, it was actually mostly that a lot of compilers didn't really do C99 really well in a standard way, so it was just asking for more problems. And now when we have an established source code using this already, the motivation to bump the standard is slow, I would say. And maybe we bring it up every once in a while and discuss it, and then we stick to C89. All right, anyway, we have this great, of course, community that when people can sort of inform us that we're doing things the right way. But anyway, I kind of like it when we can do these ironic pillows out of comments on my blog about what I do. But okay, so we do ship code to lots of the different things, installations everywhere. There's the question, right? 30 billion installations. How do you sleep at night when you do? I'm going to do a new release next week, right? Our 279th release or something. 172,000 lines of C code running in potentially 30 billion installations. Of course, most of these installations, they don't upgrade on every release, right? So it'll take like forever until everyone has upgraded. But anyway, potentially, if I ship a really bad thing today or next week, eventually sometime it could really, end up something heartbleed, something log4j thing in the end. And how do we make sure that that doesn't happen? And of course, securing something, I mean, for the billions, it doesn't really matter if you do it for the billions or just for 22, right? There is no silver bullet, there's no magic way to accomplish security, and you all know that, and we don't have any magic ways or magic wands either. But we start out just having a pretty rigid style guide how to write code in curl so that everything feels like it's written by a single author. That makes it easier to just read the code, debug the code, understand the code. It looks sensible, It doesn't. We don't mix styles, and we enforce the style pretty rigidly with tools and warnings if you do it wrong. And we have since a while back started, this constant battle, of course. Since we have 170,000 lines of code used in all these places, of course we get security problems every once in a while. And then when you get a security problem, you try to learn from it. Why did we do this stupid mistake? Because all mistakes are stupid, right? When you look back at them, should have thought about that. So what do we learn from all those stupid mistakes we've done through the times? Some of the things we try to say, at least tell ourselves, is that sure, it would have been better if we would have avoided a few of these stupid, especially in C, some of the APIs in one of those, a few of the original libc implementations, they're not, maybe not stupid is not the right word, but they're sort of error prone. It's easy to use them wrong or easy to end up in a situation where the code potentially looks right, but it's actually wrong. So we have over time went through and said that we should stop using these functions and we should implement our own sort of wrapper versions instead in an attempt to avoid future security problems involving those functions. So we ban a bunch of them, like, scanf or whatever. We don't even do A2I, we don't use. Well, we're adding a bunch of functions over time that we're trying to avoid to just make us write better C. And we also nowadays have, I have had an effort over the last few years actually to reduce the complexity of all functions in curl. You just measure the complexity level of every function and make sure that we're below a certain threshold. It's an interesting exercise, and it's the idea being that by having easier, less complex functions, they should be easier to read, easier to analyze, easier to understand and debug, and possibly then have fewer bugs in them. Let's see if that works out. Another thing about doing things for a very long time and having security reports every now and then is that when people report security bugs on curl, which people do at a really high frequency, but every once in a while they're also right. And then we go back, and one of my peeves about doing that is making sure, when did we insert this? Okay, we did a security problem, we have added it, it's confirmed. When did that problem get into the code base? Let's learn from that. And then the average time a security problem has existed in curl when we find it is 8 years. So 8 years ago, on average, we inserted a bug that they find today. So that gives us this problem. So when we fix something today, trying to make our process code better for security reasons, when do we know that we actually succeeded, right? When the average time is 8 years back. So it's really, really hard to say, when do we know that we have actually improved? I don't know. At the same time, we're adding new code. So it's really, really hard. So a lot of these things that we try to do to make curl safer, more secure, they're really just shot in the dark. Sounds sensible. We agree that it's a good idea. Will it help? Ideally, hopefully. Of course, we review all the changes or whatever. Whenever someone suggests a change, we have human reviewers. Nowadays, of course, also we have all these different AI review bots helping out as well. So there's a lot of review of different kinds. ideally that should also help us avoid problems. Over time, I mean, I think when it comes to open source in general, and Curl, of course, is no different here, is that sometimes during the years, I've been doing this quite alone. When you do something alone in the night and you submit a pull request, hey, we should fix this, we should do this, and there's just crickets out there. There's just no one to review my code. And I'm the only one who's getting paid to do this. I can't demand a review from anyone. So I have a change I want to do. I think it's the correct one. Maybe it fixes a bug, maybe it adds something. And there's just no one around to review it. So of course, the ideal case, I just wait until someone reviews it and say, good, because that would be the best case for security, right? But that's not how the world works. So in many cases, I'm going to be the one who review my own code. And of course, that's less than ideal, but that's just how it works in reality. And of course, what we learned from the XZ attack is binary blobs in Git is potentially a really, really bad idea. I mean, who knows what kind of secret payload is in the binary blobs, as we learned from XZ. So we've really made a big effort over the last, well, basically since XZ, so we don't have any binary blobs, and we also avoid everything that is even just base 64 encoded, because base 64 could then also potentially, at least make it less visible exactly what the data is. So we've made a strong effort to avoid even base 64. There's no hidden secrets anywhere in the code base, so that just make it even easier for everyone to just, well, scrutinize it, read it. Can you find anything sort of suspicious in there? You shouldn't be able to, and we should make everything visible and reviewable. And similarly, everything is explained everywhere, not only the external APIs, but also the internal and the documentation, so that you can actually learn and understand why things are done in ways, which also then ideally helps us write better code, but also helps everyone to review the code better, because it's well explained in lots of documentation. And of course, adding tests is the way to do it, right? It's just plain old engineering. That's how you do software engineering. You write tests for your code, and the more tests we add, the better the code is actually. And the more tests we have, we also then address this sort of the risk when people, when I say 30 billion installations, then people in security-minded sort of circles, they think, well, what about the malicious attempts? How many kind of bad people, pull requests, have attempted to land a backdoor in curl, right? But having a bazillion of tests makes it really, really difficult to add a malicious backdoor into the code, because it's really, really hard to add a backdoor and all at the same time keep all the tests running. It is, I actually never even seen an attempt to provide a backdoor. And I think that's one of the ways also, not only to keep, make it really hard to make something malicious, it's also a really good way to actually just up the bar for contributing, like with an AI written contribution. Because if you don't, if your PR, if it doesn't sort of mostly go green on all the tests, then I don't really care. Then that's a really good way to sort of, for me, to dismiss whatever. It doesn't really matter if you're using an AI engine to write some crap, because if all the tests are red, I don't care. But if all the tests are green, well, then it might actually be a good contribution, and then it doesn't really matter if you wrote it yourself or with an AI or someone else helped you do it. So many tests is really a key to do everything. And of course, to run all those tests in CI like crazy. So we have over 200 CI jobs building on, I think, 10 different platforms in a bazillion different, And one of the problems with curl is that we can also have a lot of features on-off, different backends on-off, which gives us a really, it's not an endless number of combinations, but it's close to, it's actually billions of build combinations. So we can't test them all, but we can test all the common ones and different mixes in different combinations. So that's what we do. And then, of course, we use all those, we're using C again. So we use Valgrind, and we hold all these sanitizers with all the compilers, the undefined behaviors, the overflows, the memory, the address, and sanitizers to make sure that it could be potentially memory safe. And we're using all the different static code analyzers we can use. All the free ones, we're using some commercial ones. We're signed up on all all those new fancy AI-powered code analyzer things from OpenAI, from Augment View, from whoever whoever provides them, we sign up and we run them too. And of course, nowadays, if you want to do really fancy code analyzing on code, they are the most fancy ones are of course AI-powered. Compared to the old non-AI-powered code analyzers, they find a lot more. So it's really taking code analyzing to the next level, and we're using that, and of course, to fix even more bugs and more potential problems in kernel. And of course, we run fuzzing. Fuzzing is really, I mean, by now it's old news, right? Of course, you fuzz your stuff. So we fuzz curl on the Google OSS Fuzz project, so they fuzz curl non-stop on Google infrastructure since 10 years or so, basically just throwing junk on every API that we have and making sure that everything still is fine, no leaks, no crashes, and just returning error when it's supposed to. An awesome way to test APIs, test everything. Of course, over time, it basically just sits there eating junk, and it basically never finds anything anymore. But that's also good and a verification that we actually do a lot of things decently. And of course, one thing I think, especially just the other day, right, there was this more papers about how all the CI jobs and GitHub actions and everything are being attacked by different ways, extracting secrets or whatever you do on those machines that you actually run on CI and everything. But one of our benefits here is that we only run CI, we only use all of those in a read-only mode, so they never write anything back, they never actually upload anything, we just run them as single-shot jobs. So even though if one of those cloud machines gets attacked somehow, they actually cannot affect us back. Of course, they can still run Bitcoin mining or whatever, but they still don't actually, they can't get back to us, which is convenient. And of course, we do, again, back to lessons from XZ, we do fully reproducible releases, so anyone who actually wants to can then verify that whatever I release next week is actually the exact same binary contents that you would do if you would do the release the same way as I do it. So just a transparent way to make sure that I didn't actually insert something malicious in the process when I did the release, which is just another way to build trust and certainty of whatever we ship. And of course, we do these simple things as we sign commits, releases, tags, whatever, so you can actually be sure that whoever did those things are the persons who actually claim to be those persons. All of these, different things that we can just do in engineering to make all the little screws as tight as possible. We're tightening every bolt. And of course, we had a few code audits by external companies, security expert people spend a busload of days reading curl code and saying it looks good or bad. I think we've had 3 different audits. The most recent one, a little over a year ago, they found no particular security problem, just had some advice on how to do it better. So it pretty much, it helps. And of course, we have 2FA for all committers and who actually are allowed to push to the Git repository. So these are just, one by one, they don't add a lot, but as long as we have all of those and we make sure that we stick to them, that's what we do. That's the best we can do, I think, to make sure that we actually are secured for the billions. Hopefully we are. And I do this since a long time, of course. My share of the commits, or my number of commits is in the red line here, and the blue line is everyone else. So as you can see, the blue line is catching up with me here. So by projection, they will sort of pass me in a year or two, and then I will have had less than half of the commits in the current project. We have a lot of authors every month, so on average, maybe 20 different authors per month. First-time authors, I think this is an awesome metric because, of course, we want newcomers all the time, right? We don't want to... The graying open source is, of course, a real problem, and I'm certainly not the exception here. I'm the problem personified. But getting new people into the project is really important, and I think it's also a good measurement to show us that we're doing things still right. As long as we get new people in, at least we're doing some things right, and we're keeping things easy enough for new people to do that. Even though, of course, again, back to having C, writing things in C, that's really a way to make it really hard for people, because people don't learn C these days, so it's really becoming a niche thing. One of my, as you can see, I'm having a sort of a graph addiction, so I have a lot of graphs. But here's one of my graphs I enjoy the most. The number of people with code left in the production code when you do git blame over time. So basically, it's, nowadays we have a little less than 600 names when you do git blame on production code. So it's certainly not just me, but there are 600 persons with code left in production code. So yeah, I do this. I actually learned to do about 2 hours of spare time coding a long time ago in the 90s, and I studied like that. So I've been doing that for a long time. Started doing curl part-time as my paid work from working from Mozilla in 2014. 2019, I started doing curl full-time and spare time. So nowadays, I count roughly 30,000 hours spent on curl. And of course, maintaining curl, in a particular, this small kind of project, means that I am the only one who's doing this full-time. That means a lot of things fall on my shoulders, right? Because I can't really expect anyone else to do this, so most of this I do. If I want it to be done, within a controlled period of time, of course, I can ask someone else or can hope that someone else does it, but I can really never depend on it. So it gives me a lot of things rather than doing feature development, perhaps. So over time, of course, I do less and less of developing things and more of all the other things. But it's fun. I still think it's fun. 30 years later, this is still living the dream. And having done it for 30 years, running on 2 planets, 30 billion installations, and here's the time for... So I got this one in 2017. So this is my Poland Prize Award, and I actually gotten 2 more medals last year. So I'm sort of starting to collect a few of those as well. So that's awesome. And one of the challenges to having done curl, as I say, fairly solid thing. It works for most people. One of the challenges then is to do this full time and actually get paid, because I give it away for free. Anyone is completely able and free to just use it. And in this fun slide, you can see these cars run curl. I mean, that's you can't find many brands in here that run on the streets. So basically all cars. There are a few brands not present here, but they might use curl as well. It's not that easy always to figure out if they actually use curl or not. These ones I know use curl. That's a lot of curl in a lot of cars. So surely they help out, right? No, they don't. So so it's really, being everywhere is certainly not a guarantee to get paid. And it's getting money out of giving code away is a challenge. And it keeps being a challenge, even if you run in many places. Anyway, so I think still, I just wanted to come back to mention that people are still more difficult than code, and it's certainly, that just gets more emphasized the longer you work in this. So code is always easy. We can always fix the code. We can always just patch it in another round, do another release, but people are always going to be the most difficult thing. And maybe the second most difficult thing is, what do we do from here? What's the way forward? You know, the path into the woods. What's the next step? What's the right to do? And people, having been around for a long time, and it's so easy to see what we have today, look back through the time, and you think that it seems natural that, that progression back, it was natural to come to this point. But it's never natural, right? Every day there's a decision to do. Is this the right way? Do we actually need this feature? Is this the protocol to do? Should we do the protocol this way or that way? And it's an endless number of tiny decisions that it's really, really hard. From my point of view, I always try to just look at the ground immediately close to my feet and say, is this the right decision to do for whatever we need to do this month, next week, or maybe a few months into the future? But it's really, really hard to say. So I don't have any ideas. I don't know what we're going to be, where we're going to be in 2 years. I don't know anything about internet protocols in 5 years. And really, mostly I don't need to care. I just stick to my business. I will fix curl for whatever we do just now. And it tends to often work out decently well. But I do have some ideas about the future. The future is going to be, pretty much whatever we do in society today, electronics, computers, anything, if it's not powered, it's going to be powered soon. And whatever is powered is going to be the thing everyone is buying. It has a little LED on it. It has something else, stupid things. But whatever we have today that's not powered is going to be powered soon. And when it's powered, it's going to be networked. And when it's networked, it's going to be internet. And when it's internet, it's likely to be curl in there somewhere. And this goes for anything, basically. And I think this is a trend. We've seen it if you just think back. 10 years ago, your bathroom scale, your toothbrush, or your coffee mug, they were not internet connected 10 years ago. But they might very well be today. Or in 5 years, they are going to be. Or all the other things, they're going to be internet connected too. And maybe not all things, but hey, I'm remodeling my kitchen right now. There's not a single stove, oven, dishwasher. They're all internet connected today. And you can't buy them without internet connection anymore. That was not the case 10 years ago. You can possibly argue why, but I don't do that here. I'm just watching the trend. So basically that means like this. So over time, there's going to be more stuff running curl. That's my basic prediction. And the future is not going to end. It's never going to get done. And protocols, internet, how we do internet, keeps evolving, and it's changing all the time. We don't do transfers the same day today as we did 5 years ago, 10 years ago. It keeps changing. We bumped versions, we bumped cryptos, we add new things all the time, and curl keeps up. Because if we want to make sure that, if we want to provide internet transfers the way everyone wants them to, we need to keep up with how to do it, and how the browsers do it, how the web works and everything, how the internet does. And open source truly survives. We don't ever, if products lifetimes, they come and go, but open source survives. We just ship a new version, and we can bring it to the next operating system, to the next CPU, and we just carry it on with us, and we just fix the bugs, polish, iterate, and there's no slowdown. And I don't see any really big next thing. Possibly people can, AI, but sure, we're still going to do internet transfers. Someone is still going to do the internet transfers. And sure, you can do the internet transfers using AI, but curl is going to be there and do the transfers. At least for the foreseeable future. Who knows? I can't tell the future. I just wanted to end with one of my best getting a lot of good emails from people. This is one of my favorites because it's it's such an optimistic view of the world, I think. 11 years old, using the curl API and asking me questions. That sort of brings me hope for the future and for the kids and whoever. I've written a lot about everything that is curl in this book, and that's how it works. Any questions? Thank you.